Hello, GIV ESAT students. My name is Eric. I'll be one of your lead faculty this week. And during our time together this week, we'll be focusing on the physical components of in-stream habitat. And I think the physical habitat can be a little bit more ambiguous than biological. We're talking about what lives in the stream, and chemical, we're talking about certain levels of either nutrients or different aspects of water quality, DO, temperature. Physical can be a little bit tougher to wrap your head around. So I put together a little bit of presentation to introduce kind of how I'm thinking about physical habitat and how it relates to what's happening on the landscape and how we can assess it in the stream. And then I'll walk through the assessment we'll be conducting at your respective study sites. So when we talk about physical habitat, what we're really talking about is how the living elements of the stream and the area around the stream, so like plants and trees, how those influence physical habitat conditions, and how the abiotic factors, the non-living elements, so sediments and substrate, rocks, and the water just moving through the system, how those all interact to create habitat conditions in the stream. And really, this is a reflection of what's happening on the landscape, what's happening around the stream, and how water is running off that landscape, how it's moving through the channel itself, and how that interacts with the stream banks and the bed of the river to create habitat. So when we think about streams on the landscape, where do they occur, right? They occur generally at lower points on the landscape, and the landscape they drain is called the drainage basin. So they are gathering the water that comes off the landscape and draining it to a larger body of water, eventually, an ocean or a lake. What's really cool about that is we can sample a certain point on the landscape and get a really good sense. We can sample a certain point on a stream and get a really good sense of what's happening on the landscape above that. So, here we see rivers making their way through forested watershed here on the left, an urban watershed here in the middle, and an agricultural watershed here on the right. And if you are sampling at any of those points where the river is receiving runoff from those areas, you can probably make a pretty good guess at which type of area that stream is draining. And another aspect to think about, it's important to think about when trying to consider where a river lies on the landscape, is what does its shape, what does its form look like? So on the left here, you see a picture of a river that is draining. You can see the mountain behind it. It's a headwater stream, meaning it's the beginning of a drainage basin, the upper end of a drainage basin. And that water is flowing off that landscape pretty quickly. Looks like fast moving water. And the channel itself is fairly straightened. It's the water is moving through there with considerable force. Compared to, the picture on the right is maybe what would be more typical of a river lower in the drainage basin. It is meandering through that landscape. So when we talk about a river meandering, it's really those that shape of those bends and crossing back and forth over the landscape. So when we talk about stream morphology, it's really what is the shape and the form of that channel, and that's going to differ depending on where you find it in the watershed, and also based on what's happening on the landscape, which is a theme that we'll continue to touch on. Another critical aspect of physical habitat in the stream is what's happening around the stream. So not just everything in the landscape, but that area right next to the stream is called the riparian zone. And that has important implications for what we'll see in the stream. You know, if you have a lot of vegetation there, it's going to provide some filtration that will impact the water quality. Those roots in the banks are going to create some resistance to erosion, create some bank stability. And those plants and trees are also going to provide organic matter, you know, leaves into the system, and also provide shade to keep the river cool. So the area right around the river plays an important role in what we actually see in the channel itself. And I work on the physical aspects of rivers daily, and one of the reasons why I think the physical side is so cool is that it really helps set the conditions for the biota that we end up finding in that habitat. And this graphic here, it's called the river continuum concept, and it also relates back to what rivers look like at various points on the landscape. So on the upper part of this graphic here, that's going to be your headwater type stream where the drainage basin is pretty small, and the riparian area has a significant influence on the river channel itself. The biota that live in that section of river are going to be adapted to utilize all those inputs from the riparian area, and the fish species are going to be cold water species. They're going to prefer that shade that is provided by that riparian area. And as the river channel moves downstream, and as the riparian area becomes the width of that becomes less to the river channel itself, it's going to have important implications for the biota that live in the stream. The bugs in the upper portion are going to be more shredders. They're going to be able to utilize those large organic matter, you know, whole leaves and so forth. And then as you move down, the bugs in the middle here are going to be more adapted to utilizing what's left over from that coarse organic matter. So they're going to be utilizing fine organic matter, and light is also going to be becoming more significant as there's more open channel. That's going to be forming more of the energy base, the trophic base, the base of that food web for that system. And the fish are also going to be, you know, more adapted to kind of warmer water. And finally, as you move downstream on the landscape, and you have those larger meandering rivers with a lot of open area, a lot of the organisms you find might be more adapted to utilizing the sunlight in those open areas. And you know, this is a good example just of how the channel and what it looks like on the landscape kind of dictates some of the conditions that biota utilize and prefer. So we talked about morphology being the shape and form of a river. Well, there's fluvial geomorphology, and that's a process that really dictates how sediment and water interact with the river channel to create that shape and form. So rivers are always adjusting to what happens on the landscape around it. And it's going to try to keep its sediment regime in balance with its water, its hydrologic regime. And it's going to keep that in balance by the process of erosion and deposition. It's going to, erode some areas of the stream, enlarging that channel, and it's going to deposit sediment in other areas of the river, creating more shape and more complexity. And as these processes play out, it's trying to find this equilibrium, where these two regimes are in balance, essentially. And as things happen on the landscape, though, either the sediment regime or the hydrologic regime changes, the river channel will try to change too. So this equilibrium is dynamic in that it's responding. The river responds to what is happening on the landscape. And this geomorphology plays out, this process plays out, we can see it play out in what the river actually, what the shape of that river looks like. So it's important to think about these two really types of riverine habitat, pools and riffles, and they're gonna repeat in those meander bends. As a river bends, the pools are going to happen in those bended areas, and as the river kind of comes back and turns the other way, you're going to find these shallower riffle areas. And we'll assess some of these areas in our habitat assessment itself. So the pools are these deeper, slower moving areas, and the riffles are these faster, shallower areas. And as we think about erosion and deposition and the river adjusting, one way to think about it here would be if you have a straighter river channel, which is this top picture here, and you were to make a change on the landscape in which more water was running off faster, the channel was experiencing higher velocities, you would see the channel erode on its edges to create longer meander bends to dissipate that energy and to balance out that hydrologic change. And this has important implications because we think about rivers on the landscape generally as being static, and houses get built next to rivers and roads get built next to rivers. But as we do things on the landscape, the river is going to want to move. And so that has an important implication for some of the infrastructure we put around rivers. And this is a process that really plays out over time. So it's a little bit abstract, but we can actually see it as it's played out in the past on the landscape. So in this picture on the left here, on the top half, you can see the river meandering through that landscape, the sequence of pools, riffles, meander bends on the upper portion. And on the lower portion of the picture on the left, you can see where the river formerly meandered through that same landscape. You can see the channel filled in there, and the course of meander bends that have been abandoned, and the river has found a new channel. Now, we can also see this play out in Burlington, where UVM is located, and we may even be able to get to this site here. This is the mouth of the Winooski River along the border of Burlington and Colchester. And you can see as the river meanders and turns through this delta, it used to flow over here, over to the right more. You can see that oxbow is what it's called. It's a part of the channel that's now been abandoned by the river as that river charted a new course. And you can see some of the infrastructure around the river. So as the river moves in the future, there needs to be, rivers need to have some ability to move. And that's something that people have been thinking about more and more now, as we've learned more about how rivers, river processes work. So we'll be taking a look at our study sites through a physical habitat assessment that is an EPA protocol, and it's going to grade out 10 different elements of physical habitat structure, really, and through that we'll be able to not only be able to grade out, okay, my study site is in this condition, but also from that we'll be able to make some guesses about what our biological and chemical metrics might look like, and also but what's happening on the landscape around us. So the first of the 10 metrics that we'll grade out is called epifaunal substrate and cover. And that's a pretty complicated name, but to me this is really about like what's the diversity of structure present in the river channel. So in the picture on the left here, you see fallen logs, and those are creating some shade for species. And if they're in the stream, they're creating different sort of water patterns that are providing different types of habitat. And you see big boulders where fish could hang out and look for food. So there's a lot of, I think about that as habitat complexity. There's a lot of kind of micro habitat in that type of setting. On the right here, it has a good riparian zone, but really in stream, there isn't much complexity to it. It's really just the water moving through the stream. The more complexity present in the stream, the more opportunities for habitat there. And that we're going to grade this out along a gradient that will be able to kind of place where our stream fits in this spectrum. Embeddedness is a really important one, and again, it's important to have that background on river processes, because some of the river adjustment, you can see it manifest in some of these metrics, and embeddedness is a good one. So on the left here, you can see the substrate, the bottom of the river channel is made up of kind of coarse material, larger rocks and so forth. And if you think about this in the water, between these rocks, there's a lot of space for bugs to live. There's a lot of microhabitat again. That there's a lot of complexity there. There's a lot of space for biota to find places to eat food, find places to rest. That looks like good habitat. On the right, the space between those coarser material, the larger material, is all filled in with finer materials like sand and silt, and that doesn't provide the same habitat opportunity for those bugs and biota. And this can be an indication that that there's that sediment water regime is out of balance. There's really too much fine sediment in this river channel, and it's impacting the habitat. Our third element that we'll take a look at in the habitat assessment is really the diversity that's created by the way water moves through the river channel. So on the left here, you see some diversity. You see some riffles dictated by the whiter, faster moving water, and some slower moving water up front here. On the right, you see a stream that looks like the flow is interrupted by a beaver dam. So you probably have a lot of slower, deeper habitat. And if you have more of these velocity and depth regimes, organisms have preferences for what they like in terms of velocity and depth. So a diversity is going to provide habitat for more types of species. Whereas if you have only, one or two velocity and depth regimes, there's less organisms that are going to be able to find habitat in that type of system. Sediment deposition is it's kind of getting at the same type of process that embeddedness was getting at, but looking at it in a bit of a different way. In terms of, we talked about rivers trying to find a balance between their sediment and hydrologic, their water regime. On the left, you see a river that looks like it's found its way through the landscape pretty well. It kind of looks to be in balance. You don't see large amounts of sediment sort of interrupting the river flow. Whereas you do see that on the right, and you see what is pointed out by that arrow is what's called a point bar. And that means in that part of the channel, the river has deposited a lot of sediment there. And that means that, there is more sediment in the river than that channel can really move through effectively. So that river is going to try to sort of straighten itself out to be able to move that sediment through. And that is indicative of a river that's just going through that process of adjusting and finding equilibrium. Channel flow status is another way to think about kind of the diversity of habitat provided by the way water moves through the channel. So an optimal situation will have water filling the whole channel, and that's going to provide the most amount of habitat and the most diversity of depth and flow regimes. On the right here, you see a lot of the channel isn't filled. The water is sort of forced to one side of the channel, and another part of the channel is dry. Aquatic biota need water, so that channel is going to provide less habitat for fish. It's going to be less quality habitat in terms of how we grade out this metric. The sixth aspect we'll grade out is channel alteration, and to me, this one's really about all about do we see signs of humans trying to put the channel in a certain place on the landscape, because we know rivers move as they try to adjust that process, as they're in that adjustment process. On the left here, you don't see any channelization. That river looks to have found its own way through the landscape. On the right, you see pretty significant channelization, both in terms of that bridge there. That's a human-made structure that's forcing the channel through the center of that bridge. And then you see a lot of fill placed in the forefront of the video. And that again is trying to put the channel on that certain point in the landscape. And the river will eventually find where it wants to, where its sediment and hydrologic regime kind of dictate where it should be on the landscape. So if you see this, the reason why this would grade out poor is because there's likely that channel is going to adjust, and it's probably not going to be stable in that place. So it's going to that habitat is going to be changing around quite a bit. Frequency of riffles really gets at, are you seeing that typical shape of a river where it meanders through the landscape and you're seeing pools and riffles, and then, more erosion and deposition, and another pool, and then another riffle. You want to see that pattern, because that, again, that provides more diversity of habitat. On the right here, you don't really see those riffles. It's just slower moving water, and it's in a pretty straight. It looks to be pretty straight, so you don't get that diversity. Those river processes aren't really kind of working the way they should, so that would grade out lower on our sheet, obviously. Bank stability kind of, if it goes back to kind of that channelization question of, if the river is going to be adjusting, those banks aren't going to be stable. You're going to have a lot of erosion. The habitat's going to be changing. So on the left here, you have well-vegetated banks that are going to provide bank stability through the roots and so forth. That's going to provide stable habitat. So that's going to grade out on the higher end of the spectrum. On the right here, we see banks that don't have that sort of structure. So, the roots aren't there. They're not binding kind of the banks together. This bank is more likely to move and adjust, and so the habitat won't be kind of persistent there. So that would grade out on the poorer range. Bank vegetation gets at the same type of question and habitat value, really, but through a different. The previous one is really, do you see evidence of the banks moving? This one's more directly looking at, okay, is vegetation present? So on the left here, you see vegetation present on each side of the river channel. That's going to be providing shade. It's going to be providing organic matter. It's going to be providing that bank stability. On the right, you see vegetation present on one side, but on the other side, it's completely bare. So that side would grade out much, much poorer on our assessment sheet. And it wouldn't be providing, rightly so, because it wouldn't be providing that habitat complexity. And then riparian zone width gets, we can see three questions here, really all focused on the riparian zone and different elements of the structure it provides. So, it shows how important the area right next to the river is. And this gets at more, not just vegetation and evidence of erosion, but does the river have that space to move and interact with the landscape around it? So on, the more space it has, not only the more filtration and stability and habitat it can provide, but the more space it has to move. And the less space, the more subject to sort of human impacts that channel is going to be. So on the left here, you see pretty wide. This is really looking at the width of that zone. You see pretty wide riparian areas on each side. And on the right, you see at least one side here that doesn't have that vegetation. But not only does it not have the vegetation, there's only so much space from the bank to that road. And that's going to, even if there was vegetation there, it's going to limit it to some extent. So that actually concludes what I will cover in this presentation, in this sort of introducing our field sheet. But there's a lot more elements of to physical habitat, thinking about like sort of the hydrology, how water moves off the landscape, and the hydraulics, how it actually moves through the river channel itself, that that I work on a daily basis and would love to kind of discuss with you guys over the course of our week. So I'm super excited for our week together. It's a time that I get to move from applying these concepts to really sharing these concepts with you all. So I'm really excited about it, and I look forward to spending time together this week. Thank you.